Good morning, good afternoon, or good evening to everyone. To all of you joining us from different places, on behalf of Antarctica InSync and the European Space Agency, we are really delighted to welcome you to our first webinar on Antarctica InSync. This session is part of a two-part event designed to accommodate different time zones. The webinar will be held again on Thursday with the same content and speakers to ensure broader global participation. Over the next 2 hours, you will hear from leading scientists working on key Antarctic research teams, including sea ice decline, ice shelf melting, carbon and nutrient cycles, biodiversity, and human pressures. Together, these efforts aim to support a more integrated international approach to polar science under the umbrella of Antarctica InSync, an endorsed program on the United Nations Ocean Decade. We are pleased to introduce the Antarctica InSync coordination team, who are supporting this growing international initiative. This initiative. And before we begin, let me introduce you our coordination team. We have Ange Boetius, who serves as chair of the Antarctica InSync steering board and plays a central role guiding the strategic direction of the program. My name, for the people who don't know me, I'm Diego Filun, and I coordinate this initiative, working closely with all partners and teams involved. We have Julia Ragneri, leads our logistic coordination, helping to connect research planning with field operations. We have Nico Vivo, support our effort on international cooperation, strengthening ties between institutions and across regions. And last but not least, our scientific leadership is in the hand of Stephanie Arndt and Alexander Haumann, who are guiding the development of our research teams and collaborations. Now, a quick look at today's agenda. We will begin with an introduction to Antarctica InSync, followed by short presentations on current research activities related to remote sensing, modeling, southern ocean processes, sea ice sheet dynamics, biodiversity, human impact, and atmosphere feedbacks. 2 question and answer sessions will give you the opportunity to engage with our speakers. Throughout the webinar, we invite you to submit your question via the Padlet link provided in the chat. You can use this link to post questions to any of the speakers, and we'll address as many as possible during the Q&A session. We also like to know you that today's webinar is being recorded and will be made available afterwards on our YouTube channel or website. If we run out of time and are unable to address all your questions during the question and answer session, we will compile a summary document with the remaining questions and answer and distribute it to all participants after the event. And with that, I'm very pleased to hand over to Stephanie Arndt and Alexander Haumann, who will introduce Antarctica InSync.
Yeah, good morning, everyone. From my side, I'm Alex Haumann. I hope everything is working fine with the screen sharing. Otherwise, my colleagues, please let me know. Yes, so today I wanted to give you a little bit of an insight into the motivation for Antarctica InSync and why we need to carry it out now. Why there is a lot of urgency in doing circumpolar observations in the Southern Ocean and Antarctica in the coming years. So we all know that globally sea surface temperatures have been rising, as you can see on this graph from remote sensing sea surface temperature changes from 1982 to 2016. But what we see in this graph also is that there is actually a cooling in the Southern Ocean and around Antarctica in this period. We know that some regions of Antarctica in this period have been warming, but some regions have been actually not responding to the global changes as quickly as other regions globally. This also reflected in an increase in Antarctic sea ice over this period that gave the research community a lot of puzzles to solve. And I think probably the question is not fully solved yet, why the sea ice has been increasing in this period. But then in 2016-17, we saw that the sea ice drastically declined. The region around the Southern Ocean and Antarctica has been warming very strongly at the surface, the atmosphere. There's been an increased frequency of heat waves in this region. So it seems that the system has changed almost 10 years ago now, very drastically and rapidly. And we haven't been able really to predict these very drastic changes so far, and they came very unexpectedly, and the changes seem to be very strong. So there's an urgency in understanding this region better, and probably there is no time to wait until the IPY to do circumpolar synchronized efforts in the community. Therefore, the community developed this plan for a circumpolar internationally synchronized observational year with year-round measurements in the Southern Ocean, internationally coordinated. This program has been registered with the UN Ocean Decade as a UN Ocean Decade program. The goal of Antarctica InSync is really to collect internationally coordinated observations in this region to tackle key challenges in the Southern Ocean and Antarctica, with year-round observations, especially in the sea ice, in the seasonally sea ice covered region and the continent where we have large data gaps. It should be an observing network that integrates ship-based observations, autonomous platforms, remote sensing efforts. And it should be multidisciplinary observations across physics, biochemistry, biology, the ecosystem, pollution aspects, and so on. It should integrate modeling efforts from the beginning, and we will hear more about this later. We also intend to unify measurements circumpolarly in terms of the variables, but also in terms of the protocols, how the data is collected, in terms of the metadata, how it's recorded, and data publishing. So far, the Antarctica InSync partnership is very large. It has been growing over the last couple of years tremendously. So far, it's 26 partner countries that you can see here, some of them, as well as some more on this slide. So you can see it's growing. There's also some partners that are currently in discussion. So this list will continue to grow. We are also very delighted to have very strong institutional partners such as ESA, who is kindly helping us to organize this webinar today. COMNAP has endorsed Antarctica InSync and supports the program. SUS is an official Antarctica InSync partner and has started to form an internationally distributed data task team for Antarctica InSync that's supported by the national centers. You can also see the contacts for these working groups here if you would like to get in touch with them. There is also a proposal pending with SCAR for Antarctica InSync to become an action group within SCAR. And there is also support through the SCAR Equity, Diversity and Inclusion panel at the working group, and you can also find the contacts here. This is the longer term perspective in which Antarctica InSync is embedded. Antarctica InSync is meant to be a stepping stone into the IPY5 that's happening in 2032, 2033. And you can see it highlighted here on the bottom. That's the UN Ocean Decade, as well as the Antarctica InSync observational period from 27 to 29 with a synthesis period in 2030. So really what we intend to do with Antarctica InSync is to build a community around these topics and really also carry on these activities into the IPY, also our data sharing and data collection protocols into the IPY. Maybe some measurements can also be connected to the IPY period. The dedicated Antarctica InSync timeline is shown here. So Antarctica InSync has been discussed as a program for a very long time. So I think in 2019, there was a process started to develop the Southern Ocean Action Plan for the UN decade, where it was really highlighted that we need Antarctica InSync as a key program in the Southern Ocean. There's also the efforts by SUS that have been going on for more than a decade to really synthesize our observations internationally in the Southern Ocean to address very big questions, similar to the efforts from ICE in the ecosystem component. And there's also other reports such as the recent MESO report or the SCAR Horizon Scan that really highlight the need for such a program. So you can see we are well into the preparatory phase right now with Antarctica InSync. This year is about forming international working groups, and this is also what this webinar is meant to kick off. We need to develop a science plan within these working groups and, of course, write proposals for expeditions and project proposals. Then switching over to the infrastructure, this is a growing effort, and there is already a lot of infrastructure that will be available for InSync and more to come. This infrastructure is really fitting into this vision from also the SUS community to do efforts in an observing network, so to say, with research vessels, sailing vessels, ships of opportunity, the research stations also on land, autonomous platforms, instrument marine mammals, moorings, buoys, drifters, ice-tethered platforms, airplanes and satellites, and probably many more that are not listed here. Then I will switch over to my colleague Steffi Arndt, who will take it from here.
So as Alex already mentioned, Antarctica InSync is of course a huge effort in terms of infrastructure, and there we are lucky to have on the one hand already in place the so-called Polarine facilities, so the Polar Research Infrastructure Network, which kind of summarizes a huge amount of international research stations, polar vessels, observatories, data infrastructure, as well as ice and sediment core structures. And all of that is one contribution to Antarctica InSync, and where we can also like rely and build on our infrastructure and our working horses, so to say. And then on the next slide, you can see that, however, as Alex mentioned, it's not only about the huge infrastructure that might be kind of like come first to your mind when you think about going to the polar oceans, but it's also about bringing new partners and platforms. And this means, on the one hand, like sailing boats, means space science as well, as like examples that you can just see here, like the Tara Foundation, the Team Alicia efforts, the Ocean Ref, but also Schmidt Ocean, where you can see on the next slide already examples of what is in place, and where you can see here marked where the Schmidt Ocean Observatory plans to go within the next years, and also within the time frame of Antarctica InSync, which we can also use and rely on for our work in the Southern Ocean during the Antarctica InSync phase. On the next slide, you can then see one example of infrastructure that is already committed, luckily, since end of last year. And this is our German icebreaker Polarstern, where we are currently in the phase to set up a plan and a schedule where to go. There are some cruises already fixed, as you might know that we always need to supply, for example, our German research station Neumeier, and we have long-term observatories as the HEFOS, which will be served in summer 27-28. However, afterwards, we have like plans and visions that we discussed within the National Committee of Germany, but also with international partners, where we are now on the road to really like have not here only the to be discussed, but really to really fill that with life. And we are happy to share that soon, as this will be, of course, also infrastructure that is really open to be shared on an international flow. Coming from that, we now just like want to give you kind of a reminder again, like how this international scientific working group is working, and what we built up over the last month and years in the meanwhile in terms of the organization of the science community. Therefore, you can see here in the next slide, thanks Alex, the kind of structure that we have in mind. So we have, on the one hand, we have our themes that you will see in a minute. these themes provide really the scientific framework that we are working on and kind of set the overarching major challenges, as well as really underline the interdisciplinary approach. We have then, in addition to that, like as a second structure, the research area. The research areas are, of course, like really closely linked to the themes, and are the themes of sea ice, ocean, atmosphere, biology, ice sheet, seafloor, and so on and so forth. So like really the broader disciplines kind of that you can think of. And then both the themes and the research areas are then kind of anchored within the national committees that Alex mentioned before, of the nations that we have already committed to Antarctica InSync. And these national committees are really, really important for us, on the one hand, for the organization of the national interest, but then also in terms of the information flow, in order to really make sure to take everybody on board who is interested to be on board. And then last but not least, we have then also working groups. Those are groups that are of course already existing, and here of course then also contribute to the themes that I mentioned above. To just give you now one example of such a national committee, this is what you can see now here. For the German National Committee, you can see in the upper part the general coordination team that was like partly already introduced by Alex in the beginning. Here we have only one change for the steering committee head, which is now our new interims director, Martin Borsma. And then we have for the scientific coordination, you can see here now for all the different research areas, the different representatives. In our case, given that we as AVI, of course, are kind of, in pole position, also related to our German research icebreaker, we use, we then also ask other partners within Germany also to contribute here to these scientific coordination groups. And here also it's important to have it also here not only as top bottom, but also use here, for example, the given structures of APEX, for example, of the Association of the Early Polar Career Scientists, to also involve them. So then coming to these themes that we will now already mention several times. You see here on the top, on the one hand, the 5 topics that are, or themes that are already like well known. I think the first theme is round about the topic of budgets and fluxes. The second theme is about the rapid sea ice decline. The third theme is about the ice sheets and ice shelves. The fourth theme is all about the Antarctic life. And the fifth theme is about the anthropogenic footprint signatures. However, we then added already a 6th theme called the aerosol cloud interactions and radiated feedbacks. And then we have other themes that are currently under development and discussion, as for example, the theme of the climate variability from extremes to weather, long-term variability and global teleconnections. So just that you also can see here, the whole framework of Antarctica InSync is also still quite dynamic. And this is why we still, of course, also invite you to bring up your ideas and your visions, and therefore also to give you an idea of how you can get involved into Antarctica InSync. So on the one hand, we do have our website that is also like still under construction and growing every day. However, you can here sign up for the newsletter. And this newsletter, where we are really happy that we finally managed to get the first one out last week, to really get all news that are what is currently ongoing in the framework of Antarctica InSync, upcoming events, and so on and so forth. On the other hand, what we also would like to encourage you is really to get in touch with funding agencies, to write proposals, to really collect ideas within all these working groups that I mentioned that are already there. Use these like structures within your community to really build on them and shape and write research plans and research ideas, and talk then to other colleagues in the field. As well as you have always the opportunity, of course, also to submit contributions to the actions to the UN Ocean Decade. So really to put it in the big frame and to get also seen with your ideas and your scientific visions within Antarctica InSync. And also, if you are then interested on how this all is continuing and what is coming afterwards, after these webinars, just stay until the end of this webinar, and there we will have our session on what's next. Just to give you here also an idea on how we continue. And with that, I hand over back to Diego, I think.
Good. Great, Steffi and Alex. Thank you very much for the introduction talk. And now let's continue with our first talk, our second talk about remote sensing with Martin, please.
Hello, everyone. Thank you for coming. Thank you, Diego, for the introduction. So I'm going to talk about remote sensing aspects in relation to Antarctica InSync. And I'm going to use the ESA Polar Science Cluster as a kind of case study, an example of the potential for remote sensing in terms of within respect to Antarctica InSync. But I want to make it clear from the outset that this is not diminishing any other of the space agency's research programs or any research programs for any organizations. This is just more an example of how remote sensing will be of great benefit to Antarctica InSync. So as I said, I'm going to highlight the work of the ESA Polar Science Cluster. Here our work focuses on generating benchmarking data sets, so data sets looking at how aspects of the Antarctica and the Southern Ocean are changing in time, developing new processing algorithms to develop new data products, and then using those products to monitor cryospheric change, ocean change as well, and improve process understanding. So we have a whole host of projects looking at all different aspects of the Southern Ocean, the ocean, sea ice, land ice, and I'm going to talk a little bit about these in a moment. But just to sort of, as a general overview, it's crucial for scientific investigations of these regions to have remote sensing data, satellite Earth observation. It adds both the spatial and temporal coverage to in situ observations. It also allows multiple parameters to be observed at once. For instance, if you're interested in sea ice, you're doing a fieldwork based observation of sea ice, you can also get information from satellites about what's happening with the ocean, what's happening with the atmosphere, what's happening with the land ice at the same time. So together that allows you to provide this holistic view of Antarctica and the Southern Ocean. And those aspects are really what we can harness for Antarctica InSync. Just looking at the themes that Steffi mentioned before, I won't go through all of them here, but I'll just say that for each of the themes, there's remote sensing data sets that can be vitally important for those studies. So as kind of more concrete information, here again are the different polar projects that we've run over the last few years and are currently running. And this is just to highlight as well that these are just the activities of the ESA Polar Science Cluster, and they don't cover the activities of the ESA CCI, which looks at long-term records of essential climate variables, but just these projects from the ESA Polar Science Cluster. I'm just going through a few of them, and I'm going to be very quick because I know I don't have too much time. So, for example, there's the Albatross project looking at bathymetry and tides within the Southern Ocean. So improved information of the underlying bathymetry of the Southern Ocean and the interaction of tides with ice shelves and sea ice. We also have a collection of projects looking at sea ice and salinity in the Southern Ocean and its impacts on circulation. So this is the So Fresh project. This has looking at multi-year record of sea surface salinity and using that to understand the dynamics of the ocean and the dynamics of the Southern Ocean. And this project also, So Fresh, also links to multiple other projects. So Ice is an ESA project looking at ice shelves and the interactions with the Southern Ocean. So they're looking at the freshwater input. And then So Chic, the European Horizon 2020 project, looking at air-sea fluxes and ocean ventilation. So you can see here that these projects, there's 3 projects here, all with interconnected aspects, with Earth observation playing a central role there. Looking to sea ice, we have the just recently finished Cryosat Plus Antarctic Ocean project, and the recently started SOSIMBA project, which is looking to establish a complete multi-mission reference data set for Antarctic sea ice, and then to use that to determine a freshwater budget, so to understand the interactions between sea ice and the ocean. So a whole number of different products being produced from this project, utilizing a whole host of different satellite sensors. Moving towards the land, we have the floating ice shelves around Antarctica, and this was the focus of the Polar Plus ice shelves project. Here, looking to quantify the mass balance of each of the ice shelves, how it's partitioned between basal melting and iceberg calving. And then again, this is an important aspect in terms of both the stability of the land ice, but also the flux of fresh water into the Southern Ocean and its impacts then on salinity and circulation. We have two projects, one finished a few years back for the Antarctica and its new evolution into 5D Antarctica. So this is much focused on the marine ice sheet. Again, developing a multi-mission reference data set for all aspects of Antarctica, and with 5D Antarctica particularly focusing on the coastal margins and how they're changing in time. And these continent-wide projects allow us to generate a whole host of different data sets from Earth observation that can start to provide this holistic view of both the ice sheet and its interactions with the ocean. So here in this video, you're seeing multiple data sets provided by Earth observation, with some modeling as well, data assimilation of remote sensing data sets. And you can see how by combining these data sets together, we start to provide a full comprehensive view of the processes that are occurring, and we can use that to understand how the ice sheet and its interactions with the ocean are changing with time. And obviously similar things can be done with sea ice as well. And these comprehensive holistic data sets provide the groundwork for these digital twin activities. So here I'm showing a few videos all at once, but basically showing the same product, which is our digital twin Antarctica precursor, which was using those data sets generated from the 4D Antarctica project to develop a digital representation of the ice sheet, both in space and time. And you can start to explore the data sets, look at how they're interacting with one another, look at how the ice sheet is interacting with the ocean, and develop that understanding of how things are coming together. So this is solely based on Earth observation data. And those precursor projects led into a bigger initiative at ESA called the ESA Digital Twin Earth Program. This is a companion project to the EC Destination Earth, or Destiny project, which is I think it's 300 million plus project. One of the elements being developed is this digital twin component for ice sheets. And here I'm showing some slides, some screenshots from that. And the idea there is to maximize the latest information from satellite Earth observation capabilities, combined with data analytics and simulations to explore what-if scenarios and data analysis to provide decision support tools for policymakers, communities, and also scientists. And also, there's some new opportunities that have come up in the last year or so. So firstly, Biomass was an ESA satellite launched last month. It primarily focused on forest analysis, but also has potential for analysis of ice as well, sea ice and land ice, by developing these thickness maps for mapping topography within the internal structure of ice masses. And just a year ago, we also launched with JAXA the EarthCare mission, so looking at clouds and aerosols. And here I have some images from data captured over Antarctica of polar stratospheric clouds. So multiple sets of data, lots of future opportunities for new satellites, and we're only just starting to scratch the surface with these. So taking a step back and sort of considering what ESA itself can contribute to Antarctica InSync, well, we can play a strong role in coordinating the involvement of the Earth observation community. We plan to have new scientific activities funded, with the topics guided by the selection of the scientific community. So one way is through the scientific action groups and planning groups that Antarctica InSync are developing. These projects can involve both in situ and space elements, so potentially validation of satellite observations as well. We can facilitate efforts to coordinate Earth observation data sets through supporting dedicated data sets and facilitating collaborations with the other space agencies and the remote sensing community in general. There's, with all the data that comes from Antarctica InSync, we can potentially provide access or to a data space to allow collaborative research. And also part of our activities are to help events like this to support the scientific dialogue and consultation with the community. And I think Alex and Stephanie will mention some more about that in the what's next part of this webinar later on. And I'll leave it there and hand back to Diego.
Thank you, Martin. Thank you really much for your nice talk. Really complete. And before I introduce the next talk, I would like to remember that we have our Padlet link in the chat. So if you have questions, just write them there for the different speakers. The next talk is about modeling efforts. And for that, we have a shared talk between Torge Martin and Stuart Corney.
Thank you, Diego. I'd like to start with a disclaimer. Speaking about models, there's a rich world of models out there, and I will certainly not represent all the modeling efforts that are going on around Antarctica and the Southern Ocean. My focus here will be mostly more on the global climate models perspective, because these are also used to do the climate projections that are used in the IPCC reports and still have lots of face challenges around the Southern Ocean and Antarctica. And speaking of this this challenging region of the globe, of course, I provide here information that I didn't collect myself only, but I want to thank my contributors, Louise Syme, Tom Bracegirdle, Florence Corleone, and Ruth Mottram, contributing to this presentation. And models try to present basically everything around Antarctica, not only the continent, the ice sheet, the solid earth underneath, the atmosphere aloft, the ocean around, and the sea ice in between. And that's just the physical system I'll focus on today. There's, of course, chemistry in the atmosphere, biogeochemistry in the ocean, wildlife, and furthermore, that all goes also into the model world. I picked these 4 figures to start off the presentation because I think it's quite intriguing. If you look at the upper left, it's what the IPCC or CMAP models project for a 2-degree warmer world. And we know this figure well. It's showing the polar amplification of surface temperatures. It's of course strongest in the Arctic. And while Alex mentioned in the beginning that there's so far not strong warming around Antarctica or over the Southern Ocean, what's projected is also warming around the Antarctic region. And while we have this bipolar picture of the growing temperatures on Earth, we also see that the same pattern is basically true for cloud biases on the top right, for example. So biases in the atmosphere with the cloud schemes are largest in polar regions. And the same, or similarly, in the ocean, in the deep ocean, and here only represented by the sea surface temperature on the lower left, but there are strong heat biases in the ocean around Antarctica, which is in the end not only a modeling issue, but also an issue of actually knowing what's going on in the area. And you can see on the right-hand side from Goose, the figure of the current in situ observations in the global oceans. We see that the blank spots on the map basically overlap with the strongest warming regions, at least on the oceans. And this is something that certainly puts Antarctica InSync on the map for the Southern Hemisphere, for the high latitudes, to fill in these blank spaces to understand what's going to happen under global warming. And now, speaking of heat, I think heat and freshwater or the hydrological cycle are probably the core themes of Antarctica InSync in some way, and also in terms of modeling, understanding the whole system. And you see that the ocean around Antarctica is probably the actual source by evaporation of water, then feeding into the atmosphere, forming clouds, forming precipitation, falling as snow, which is the original source of the entire ice sheet in the end, on a much longer time scale. Of course, this ice returns into the ocean just by dynamics and is there melted on ice shelf cavities by carving into the ocean, and so on. And we need to understand this hydrological cycle much better, and we need to represent it in models much better. You can see on the lower right-hand side new simulations with the HELGEM-3 climate model, and also the RVESM2 model includes now isotopes. So there's ample opportunity, a new opportunity, to actually track the hydrological cycle around Antarctica using isotopes with models in combination with observations that are partly already available, but also could be much more, quantifying the oceanic moisture sources, evaluating cloud processes, basically the whole cycle reevaluated in models and in reality. Speaking of the atmosphere here, clouds and aerosols are a big issue still in models, and I think it's good that it becomes a sixth theme in Antarctica InSync, to just focus on these. You've seen the top figure on the beginning slide. There are huge issues with cloud schemes, and these actually feed back into the whole system, because clouds affect the radiative balance, of course, and therefore also surface temperatures and the interaction between ocean and atmosphere with the sea ice, but also with the land ice and snow cover, basically everything. And clouds are really important issue in climate models to be tuned correctly to understand which phase of clouds, liquid or solid or frozen clouds we have. And similar with aerosols, there's a clear issue in the seasonal cycle of aerosols, of sea salt aerosol in this case. You can see that both basically for the Arctic and also Antarctic, the bluish line is the CMIP models, and the thick line is the multi-model mean. But with the thin lines, you can see that there's clear mismatch of the observed seasonal cycle and sea salt aerosols and the model cycle, actually. And this needs clarification. Therefore, a year-round program like Antarctica InSync is most welcomed by the modeling community to understand exactly these seasonal cycles much better, and the interaction from the ocean with the sea ice into the atmosphere and finally onto land and back into the ocean. But not only speak about budgets and cycles, but also extreme events. For example, in the atmosphere, atmospheric rivers play a huge role in locally driving heat waves or temperature anomalies and strong precipitation. That could be either just over the sea ice, or these atmospheric rivers could make landfall, so to say, and dump loads of snow locally, which then you can find local observations, of course. And these rivers also drive changes in the atmospheric structure, in pushing the limit of the humidity and temperature maximum upward, which is, you can see on the right-hand side in the top panel, the mirror reanalysis compared to CMIP, NORI-ESM in this case, which is simulated by quite a set of models. It's in there. It's maybe not exactly right, but the mechanism is in there, but not in all models. So we can't always only look at the multi-model mean. In this case, it's useful to look at individual models to understand how they simulate these extremes. Another extreme case, but on a very different timescale, not on a synoptic timescale, but interannually, or actually in models covering up to decades and more, are open ocean polynyas and deep ocean convection. We've seen that only twice, basically, in the history, that in the very early advances of satellite reconnaissance, the Weddell polynya in the early 70s was present. And just in the last years, or recently, well, by now it's almost a decade ago again, the motorized polynya opened up to wider polynya. That sparked a lot of discussion. Well, still in the climate model community, open ocean deep convection is in coarse resolution, 1 degree, half degree resolution models, still a big issue, because that's how these models form bottom water. And as you see in the bottom row, there hasn't been much process from CMIP 5 to CMIP 6. Still in these models, it also triggers or imprints on climate variability, because it's a stark contrast in surface temperature and sea ice coverage and surface heat fluxes, but also in the deep ocean transitions into other ocean basins if it's strong enough as a signal on decades to centuries. So there's something that Antarctica InSync can help a lot with, understanding and observing the southern ocean hydrography better, understanding the seasonal cycle under the sea ice of the mixed layer and mixed layer dynamics. Speaking of polynyas, let's move on shore towards coastal polynyas. And We've seen a lot of improvement, a lot of great studies in these regions based on satellite, based on local measurements, but also high resolution modeling. The whole process of water transformation in the continental margin with the interaction of the ice shelf cavities has improved a lot. There are great modeling initiatives, regional modeling initiatives, like also the MESOMIP, the Marine Ice Sheet Model and the Comparison Projects is covering this some way. And then there are models with a 10th degree resolution that can actually show we have this mechanism in the models if they have higher enough resolution of water mass transformation on the shelf, transport of bottom water off the shelf dynamically correctly. But it also needs the right coastal winds. And to have this data in either atmospheric reanalysis to force ocean sea ice models or to have in coupled models, we need more concerted observations and also long-lasting observations of these wind regimes along the coast. Now, thinking that ice melt is, of course, impacting the climate system and forcing the ocean. And in this case, the ice forcing the ocean has been shown with the climate models that massive freshwater melt or melting of the Antarctic ice sheet can lead to a delay or slight damping of global warming, at least in the beginning. Also explains an increase in sea surface, and sea ice expansion in the early years, and then maybe a decline of sea ice affected by warmer temperatures. The Southern Ocean Freshwater Input from Antarctica, SOFIA initiative, has recently shown with an effort of 10 or even a dozen models now that freshwater input from Antarctica affects everything, basically from the very deep ocean, bottom water formation, to the upper ocean, strong cooling, surface cooling, sea ice expansion affects the troposphere, even goes up high into the stratosphere with these mechanisms affecting the entire southern hemisphere. So this is huge what's coming up, and we need to understand this and model this better to improve our projections, because that's a process that's not included in the IPCC style experiments at the moment, because most climate models lack ice sheets, interactive ice sheets. But it could also be the other way around, the ocean forcing the ice. That's on the one hand the sea ice, and this nice study by Burridge and Doddridge a couple of years back showed that the recent change that Alex mentioned, beginning from expanding sea ice coverage to actually strong decline and drop in sea ice coverage, was linked to accumulating heat in the upper ocean, just in the mixed layer and slightly beneath, driving likely this change, drastic change in the sea ice coverage. And it's not only the sea ice around, but of course, the temperature of the ocean, the heat that's available, without any global warming, there's sufficient heat in the ocean that just need to reach the ice sheet and the ice shelf cavities to cause drastic melting. And the issue is that the models have strong heat and temperature biases. So you see here from the ISMIP 6 project, the range of ice sheet mass loss caused by very different input models or input climate estimates of temperature around the ice sheet, forcing the ice sheet models, then yielding very different sea level anomalies by the ice sheet. And what's quite interesting, there's things happening around Antarctica while the sea ice was also changing around the same time, maybe a bit later. The surface mass balance of Antarctica changed. So there's a pause basically in the cumulative mass balance of Antarctica. Would be interesting to understand these feedbacks better between ocean sea ice, the atmosphere and the ice sheet feeding back into the hydrological cycle that I mentioned earlier. And mentioned lastly,
please wrap up in the next minute.
Yes,
Torge.
absolutely. The freshwater fluxes that we need to observe better, hopefully during Antarctica InSync. This has been mentioned not only by satellites, but in situ measurements like gliders. The carving processes need to be understood better. We have groups who drill through the ice shelves, take measurements from underneath in the cavities, which is fantastic, and of course floats in the ocean. And all this would help the modeling. And if you're interested or intrigued in getting involved in the Antarctica InSync in collaborative modeling efforts, please contact me or Louise. I will try to build something from this. Thank you.
Okay, Torge, thank you very much for your talk. Now, continuing with the agenda, it's time for our first Q&A session. So please, this is the moment to write your question for the speakers or for the, all the speakers. So let's check what we received until now. Okay.
I can maybe take the first question that's for the general introduction. There is a question, can you elaborate on the data infrastructure and data management? So far, this is under development. I would advise you to reach out to Michaela Miller, who I put as a contact for the SUS contact. She's the SUS contact for data right now, but there is a discussion already within SUS, but also within this SCAR data task team to develop a task group around this. And please get in touch with them to form a cross-cutting working group on data management and infrastructure as well. Also to mention that we are currently writing proposals to also support the data infrastructure and management centrally. So this is something that's in progress.
Okay, there is another question. I think, Torge, that's for you. Are you planning to include ecosystem models? Models including species traits, species interaction, species response to environmental variables, sea ice.
Yes, it looks like I'm not passionate kakadu because I didn't sign ein. Anyway, yes, anything can be involved. It depends on the individual communities to build a network within InSync. It's going to be too big to be handled by just a couple of people. So I just ask and I just recommend that you form nationally or internationally networks. And I think the modeling community should connect just as the observational community does. And this could be within the themes, but also in combination with the themes within a modeling network.
So I don't know if there's any more question from the audience.
There is one more in the chat. That is also to Torge. What's the single biggest circumpolar measurement that InSync could contribute that will improve Southern Ocean and Antarctic coupled models, Torge? Challenging question.
That's true. So my oceanographer soul would say we need much better handle on the temperatures of the ocean around Antarctica because the biases is way too big and it really imprints on all the other components. And I think that's where Antarctica InSync with this huge effort of ships and in situ measurements could certainly help. But not only by covering, just measuring temperatures, but really understanding the mechanisms in the mixed layer and within the surface fluxes.
There's another question in Otter. Maybe that's a general question that we can answer now. Are you planning to provide letter of support or similar for anybody planning to apply for funds to different funding agencies?
I can take this one as well. Yes and no. We are still working on a process for a project endorsement that hasn't been finalized yet. That's up to the International Steering Committee to finalize this process. But we can certainly try to provide letters of support, and we have done this in the past on a scientist to scientist level that certain projects fit within the scope of Antarctica InSync. So I think if you reach out to your colleagues that are involved in the organization of Antarctica InSync to provide a support letter, I think that's something that we have been doing and we are happy to continue doing.
Okay.
Then Fabrizio also asked in the chat, will Antarctica InSync set up a process to capture requirements in terms of the in situ measurements? That is a very good question. So I think that's also for the community to organize. So each community has its different requirements for measurements. There's different protocols. So some communities have already protocols for measurements in place and certain requirements, and these will be followed. Other communities are still in the process of developing those. So I think that is an excellent task for the working groups to make sure that either there's requirements already published or that need to still be developed to talk about those. So I don't see any more questions coming in. Then I would suggest, Diego, that we break for a couple of minutes for everyone to take a breath and have a short bio break.
Yes, so let's continue with the agenda. Let's continue with the break, as you mentioned, and we can meet here again in 6 minutes. Welcome back. So now it's time to continue with our webinar. The first talk for this second block will be Southern Ocean and Antarctic heat, freshwater, carbon, and other element cycles and their response to climate change. For that, Leah Olivier and Andrew Myers will present that.
Okay, thank you all. So this is just a quick summary of, I guess, some of the large-scale, high-level problems that we're interested in the Southern Ocean, particularly regarding heat and freshwater. Leah, could you have the next slide, please? And the next one, there we go. Okay, so this is probably preaching to the choir, but we know the Southern Ocean is really the dominant area in the globe where atmospheric heat and carbon enters the ocean, and the ocean is in fact where almost all of the anthropogenic heat that humans have generated is stored. And this is largely through the process of the overturning circulation there, which you can see on the right, with deep water coming to the surface and being transformed either into bottom water on the right or mode and intermediate waters where lots of heat is taken up. Next slide, please. And this is illustrated really nicely in this modeling study from Hugen et al. And others, basically showing that across simulations, but this is largely backed up by observations as well, the Southern Ocean is really taking up the majority of this heat, and through a combination of both wind forcing and thermal forcing, and then it exports a lot of that heat to the rest of the global ocean. So it's really important that we understand the processes that moderate this and drive it, and what the implication for this heat uptake may be. Next slide, please. And so we can see this in our observations. So on the left here, some nice plots from Kai et al. Showing that this sort of really deep band of strongly enhanced warming across the northern side of the Antarctic circumpolar current. And that's basically this export and sort of downwelling or pumping of mode and intermediate water into the ocean. The bottom right panel basically shows that this doesn't entirely hold over the entire Southern Ocean. So this is looking at quite close to the continental shelf. And you see that close to the continental shelf, there's actually a cooling and freshening that's overlying a sort of offshore warming of the circumpolar deep water. And this is backed up with individual observations. So the right two panels basically show the change in heat content in the surface waters near the Antarctic Peninsula. So in the top 300 meters, there's not a lot going on over the last 30 or so years. It's fairly steady. But if you look below that layer, so the bottom right panel, you can see a fairly steady increase of heat continuously up to 2020. And so what we're seeing is that a lot of circumpolar deep water warming, so there's this sort of a deep lens of warming that's occurring adjacent to the continental shelf, and in some cases flooding onto that. Okay, next slide, please. The other big story, I guess, in the Southern Ocean is freshwater. So the density properties of the Southern Ocean is very strongly controlled by freshwater. There's a very large source of freshwater sitting in the middle of our circumpolar view there with the Antarctic, and it's melting ice shelves and ice sheet, and also changes in the sea ice. So it's really critical we understand how the freshwater cycle has changed and what impact this will have on ocean circulation. So you can see this strong signal of freshening. This is from some of Alex's work a few years ago, which is very much surface intensified, as you would expect from freshwater injection around the continental shelves. But also there's been strong changes in sea ice. That's already been alluded to a few times here. And on the right here, you basically see a plot looking at Weddell Sea percentages of freshwater contributed by sea ice melt. And so that red line is basically looking in the Weddell Sea, is contrasted to the Scotia Sea a bit further north. And what the red line shows is this really strong boost in freshwater from sea ice melt happening around from 2015 through to 2018, and that's associated with this really strong decline that we saw in the satellite records and the Doddridge and Purick paper. So it's and this is oxygen isotopes allowing us to make these estimates. So it's really important we get to the bottom of understanding where this freshwater is, where it's coming from, the contributions of precipitation, continental melt, and sea ice melt, and then the dynamical changes this may impact. So next slide, please. So some of the obvious changes that we're starting to see that is quite possibly linked to freshwater forcing is changes in the overturning circulation, and particularly the formation of dense shelf water and its consequent bottom water. So on the left from Cathy Gunn, you see a really strong decline and possible recovery of bottom water formation or bottom water transport from the Ross Sea. And on the right, you see an equivalent change in volume in the Weddell Sea, from Weddell Sea bottom water thickness from Paul Abrahamson, with like a 30% decline in the last 30 or so years. So really strong changes there, which have been attributed to changes in sea ice formation, but also potentially freshwater forcing from continental melt. Next slide. And these have strong future consequences. This is getting back into the modeling realm, but this is why we care about these things. These plots are basically showing that we anticipate this bottom water formation to collapse into the future, up to halving of the strength of the overturning circulation in both CMIP and higher resolution models. And this has really strong consequences potentially for the access of warm water to the continental shelves and subsequent melt of the Antarctic ice sheets, which is potentially a positive feedback situation. But the dynamics of these is poorly understood and it's very poorly observed. So these are really critical questions for InSync to get at, some of these freshwater and heat processes on the continental shelf. Next slide. Next slide, thanks. Yep, there we go. So in summary, so these questions are, how is heat transported around Antarctica and stored? How much heat is exchanged between the ocean, the ice, and the atmosphere? What are the contributions to freshwater transport, precipitation, evaporation, sea ice melt, and so on? And how do these flux changes affect the ocean stratification, its circulation, its export, and property storage? And how do these then feed back onto the bigger questions we ask about global climate, the carbon cycle, and the cryosphere stability? And so there's a large number of international partners. This is obviously work that's very much ongoing by many nations. But I think InSync has a real opportunity to make some big epoch-marking observations to really advance our understanding of these important systems. And just a final message to back up what Torgia was saying on the next slide. Next slide, maybe.
I think it's coming, I'm sorry.
Well, I'll say what it says anyway. It says, I think we need to make sure that these observations are not purely observations for observation's sake. They really must be done in service of our understanding of the dynamic system and particularly our ability to model that. So I think it's really important that observationalists work closely with the modelers to make sure that our observations are best placed to really impact our ability to model the physical system. And with that, I'll pass over to Leah. Oh, there we go. That's what I was trying to say. The research priority is really improving our ability to model and therefore understand the Southern Ocean system and its response to climate change and anthropogenic forcing. So thank you. I'll hand over to Leah.
Well, thank you very much, Andrews. Now I feel like I really need to wait in between my slides because my internet connection might not be the best. But yes, I'll continue by insisting a little bit on the carbon cycle because, as Andrew said, like the Southern Ocean is critical for exchanges of heat between the ocean and the atmosphere, but it's also critical for the exchanges of carbon, and all of this is really linked. So it's linked by the Southern Ocean circulation that is very complex, and the Southern Ocean is extremely dynamic, and so this creates also a lot of variability in the carbonate chemistry. So the strong winds around the Antarctic continent are driving this upwellings that brings water that is very rich in natural carbon and that can interact with the atmosphere and generate a lot of outgassing in the Antarctic zone. But if we look at other regions of the Southern Ocean, it's not exactly the same pictures. In the subtropics and subpolar regions, the biological carbon pump is extremely efficient. And so there we have more of a sink of natural CO2 in the ocean. And on top of this, we also have the climate signal and the anthropogenic signal, because the ocean absorbs about 1/4 of our anthropogenic emissions of CO2, and the Southern Ocean absorbs about 40% of this global ocean sink. So this is also something that we need to look at, and this is something that we don't really understand. And all of this varies at various timescales. The seasonal one is one of the big ones, where in summer the biological carbon pump has a very strong impact, but in winter we don't really know what is happening because we don't have any observations. And this is what the bottom plot of this figure is showing, if you can see it, but otherwise I will just tell you and you will see it 2 slides later. But it shows a little bit the kind of uncertainties we're dealing with in the Southern Ocean for the winter period. So these are zonal averages of the CO2 flux for different products. So in green, you have models. In the blue line, it's CO2 products, so it's ship-based observations. And the blue line is ship-based observation plus the BGC Argo floats. And there you can see that the uncertainties are extremely big, and even the sign is completely uncertain of what is happening in winter. And this is because we don't have a lot of observation, so it's really hard to understand what it is happening. So some of the main questions that we can ask ourselves, I mean, the big one is the Southern Ocean a source or a sink of CO2? And how large are these fluxes, especially in winter, because there we don't know much. And so we're trying to understand the seasonal cycles and the variability of these fluxes on seasonal, interannual, decadal timescales, and what are the processes, because we guess that depending on the timescale might not be the same processes that will be driving the flux. So we need to understand the physics. We also need to understand the biology. So here we're trying to link in Antarctica InSync both the physicist and the biologist to understand both parts of the carbon pump and how all of this is changing also with climate change. And one part that I want to touch upon that also Andrew mentioned is that here I was talking mainly about fluxes and at the surface, but it's also really important to look at what is happening in the deep water masses that are formed in these regions and that can sequester carbon. But here we don't also know much how much carbon is stored in these deep water masses and how, like, what are the processes that are storing this carbon in the deep ocean. And so now we'll continue to other parts of the biogeochemical cycles, because carbon is very important, but carbon is not the only biogeochemical element that varies a lot in the Southern Ocean and that we are trying to understand within InSync. And so, I mean, it's going to be really fast, but we also need to understand the cycles of other biogeochemical elements, and one of the main ones is nutrients. So it can be all type of nutrients, micronutrients like iron and manganese, also macronutrients like nitrogen and phosphates, because they're going to regulate the primary productivity, especially the micronutrients in this region. And I mean, all of this is also rather uncertain. The sources, the seasonality, and all the link between nutrient cycling, productivity, and also microbial community structure. So here, for example, on this graph, you can see the many sources and processes that can make iron vary in the Southern Ocean, but all of this knowledge is a little bit still limited, and we really hope that in this Antarctica InSync framework we can gather more knowledge about everything, because it's a little bit the basis of the food web in the Southern Ocean. And also CO2 is not the only greenhouse gas, and so it would be extremely interesting to focus on also more potent greenhouse gases such as methane and nitrous oxide, especially in the Southern Ocean, because nitrous oxide also has a role on the ozone layer that is in the atmosphere in this region. And so it's also in this framework that we can include all greenhouse gases. And finally, another topic that we want to include in this part of the theme is chemical tracer and also stable isotopes, because they can help us understand better the physical processes, the ocean circulation, and also the biological processes, and try to help us disentangle them. But once more, we need long-term time series, we need more observations, and they're not that easy to observe. So in the framework of InSync, we're really trying to gather communities and gather platforms to try to collect as many observations as possible on many different seasons, especially once again in winter time, so we can answer some main questions such as what are the sources and sink of nutrients and greenhouse gases in the Southern Ocean, and how are they changing? The normal changes like seasonally, interannually, but also how are they responding to climate change? And finally, I will just end up by saying that we also aim to do a little bit the link between nutrient cycling or biogeochemical cycling and primary productivity, microbial community structures, and how that all plays together. So thank you. I think that will be the end for theme 1.
Okay, thank you, Andrew. Thank you, Leah, very much for your talk. Now we need to rush to continue with your second talk. That is rapid sea ice decline and its interdisciplinary consequences. And for that, we have today Inga Smith.
Great, thank you very much. So thank you for organising this, all the organisers. Thanks to Steffi, who's projecting my slides and also who put the slide deck together. So I'll be presenting today in Rushta Dardic on the 22nd. So we're on rapid sea ice decline and its causes and consequences. So if we go to the next slide. So we've already seen this graph before from Alex. So just to remind everyone again, there's been this rapid decline of Antarctic sea ice, at least within the satellite era. And so this is showing the anomaly of sea ice extent in millions of square kilometres. And you can see, as Alex said, up until around 2015, 2016, if anything, it was slightly increasing. And then more recently, we've had that very dramatic decline. And particularly 2023, it was a lack of sea ice in the winter. So sea ice not forming in the winter. So the questions, of course, are the what and the how and the why. In terms of those, what's happened, the decline, why has it happened, the causes, and what are the consequences. So the thematic areas for synchronous research in the SCAR Horizon Scan and the action plan. So there's the processes and feedbacks driving changes in sea ice extent, sea ice volume, sea ice properties and distribution of Antarctic sea ice, and its interactions with the atmosphere and the ocean. The seasonal variability of sea ice contributing to ocean air fluxes across a range of spatio and temporal scales, so regions as well as time scales. The impact of sea ice on the ocean circulation, biogeochemical cycling and biological processes, so that ice ecosystem interaction that we've just heard sort of part of in the previous talk, and the influence of changes in freshwater fluxes from iceberg melting, sub-ice shelf melting, subglacial discharge, and sea ice on ocean circulation and marine ecosystems. So these are all feeding into that core question of what are the causes and consequences of rapid sea ice decline. So in terms of the work towards these objectives, so standardized observations are needed. As Andrew said before, we need to have not just observations for observation's sake, but feeding into the bigger picture and also having those standardized, as has already been alluded to by other speakers. Surveys of sea ice and snow properties at both small and flow-sized scales. So the larger flow sizes as well as those small scales. And of course, the snow is a very critical part of the sea ice. So it increases the albedo and dramatically changes the properties of the sea ice. And depending on the time of year, it can have positive and negative consequences on the life of that sea ice. So development of comprehensive multidisciplinary network of autonomous ice-tethered platforms for seasonal observations along Lagrangian drift trajectories will help feed into those objectives. We'll need regional airborne surveys by drones, helicopters and airplanes, as Martin kind of hinted at before. Sea ice thickness from remote sensing still needs validation. So continuous generation of comprehensive seasonal validation data sets for satellite remote sensing, along with enhancements in retrieval methodologies and accuracy. That's particularly true for sea ice thickness. And then enhanced process understanding and climate models through increased resolution and refined model parameterizations. There's still some very simple parameterizations in some of those global climate models. So making that link between the process scale and the climate models is critical. So Antarctica InSync is really also a community opportunity. So there's already existing initiatives in the Antarctic sea ice community. So Aspect is the Antarctic sea ice processes and climate SCAR expert group. Has also been co-sponsored by CLIC. And then BEPSI, which is the biogeochemical exchange processes at the sea ice interface. That's the sort of biogeochemical equivalent to Aspect. And so those groups work closely together on sort of strategy for sea ice and improving observations. There's a number of international countries that are involved with Antarctica InSync. So I'm from New Zealand, but we've also got the UK, South Africa, Finland, Australia, Germany, Switzerland, Japan, Belgium, Denmark, Norway, the US, and it's growing, and anyone is welcome to join, obviously. And SUS is also a key partner in terms of those working groups, or sorry, those international working groups. So this core diagram here with the sort of upside down triangle will turn up on the next few slides. So it's trying to explain how Antarctica InSync is a multi-scale approach. And so for sea ice in particular, we're thinking about bridging the observations, the models, and the satellite remote sensing. So on the left-hand side of the triangle is the user needs. And then we've got the scales, range coverage on the left-hand arrows, and then the footprint on the right-hand arrows pointing up. So at the global scale, we've got global climate models, climate trends evaluation and variability evaluation, and obviously satellite observations are key for that, the greater than 100-kilometre scale. At the regional scale, so aircraft, helicopters with airborne data, so for example from sea ice thickness with bird measurements, and then assimilating those data, so that's at the the tens of kilometre scales. And then sub-regionally, we have the ships. As we heard before, there's a number of ships that have already been dedicated to Antarctica InSync, or hopefully will be. Drones and floating buoys. So that's at the less than 1 kilometre scale. You're getting flow size distribution and thickness distributions, for example. And then right down at the bottom, we've got the local. So the picture is literally the person drilling the ice core or taking the sea ice thickness. Those measurements and things like sea ice buoys are in the realm of sea ice process development. So working out what those smaller scale processes are that can then feed up the chain into those larger scales. And so that's usually at the less than 10 kilometre scale. And then, yeah, the footprint on the right-hand side is just giving you those size of what those footprints can capture. So there's challenges and uncertainties in observing Antarctic sea ice, and they're all slightly different depending on what you're talking about. There's the fast ice and coastal polynya regions near the coast. There's Antarctic stations and bases. So those are a good opportunity for making those measurements, but there are some limits. The pack ice needs ship measurements or overflying, but again, there are some challenges with that. And then the marginal ice zone, again, needs specialised ship work. So next slide. So yeah, so how can we address these challenges and which research methods are needed? So the essential climate variables, for example, for sea ice, can be looked at, but they don't cover everything probably that we need to know. We may need to update those. There's the scales and the processes that all need to be thought about. And so in that bottom picture there is a sea ice and snow measuring station on Antarctica. So you're getting those very localized measurements. How do you then feed those into those bigger scale models? And I think the next one is, yep. So how do we address those challenges and what research methods? So autonomous observations. So those are really essential for getting large coverage. If we're going to be synchronous, then we need to have autonomous observations as much as possible. There's the vertical climate system. Yep, vertical climate system interaction, seasonality and sequence of events. We need repetitive observations, so process studies and horizontal distribution, and we need those event-driven observations and local process studies. So I think the next slide is then the last one. Yep, so thanks. Any questions, which I guess we go through the chat.
Okay, thank you very much, Inga, for your presentation. Now we have our next talk in charge of Alexandra Sur, that will be melting ice sheets and ice shelves and coastal impacts. Please remember to keep in your time slot, please.
Yes, I will try. Thank you for the introduction. I hope you can see my slides correctly. Otherwise, just let me know. Yeah, I'm presenting on behalf of the entire Team 3 team, and I want to mention here Felicity, who's going to present on Thursday, and Olaf, who helped really helping and sharing and shaping these slides. I think I don't have to introduce the topic too much because all my speakers before me already introduced most of the topics, but I just want to highlight quickly here that the ice sheet is kind of connected to many different system parts, like the ice shelf, the oceans, the atmosphere, and the bed itself. And all of these components are shaping what is happening with the ice sheet and the shelves. And the main part here is that Antarctica contains a lot of fresh water, which is kind of contributing mostly to the sea level rise, which is causing also from Antarctica. And most of the loss is coming from the shelves, which are also going to be an important part of the theme 3. Why are we actually caring about the ice sheet? Well, if you look at the projections, and you've also seen this figure before, the mass loss from the Antarctic ice sheet is just enormous until the end of this century, or also during the next 300 centuries. And it's very important for the society to have a better constraint on the mass loss and the contributions from the Antarctic ice sheet to the global sea level rise by just having more observations of the properties and the melt rates at different temporal and spatial scales. As already mentioned, the ice shelves are having an important part here, and most of the mass loss currently is coming from ice shelves, especially in West Antarctica. And there are different processes causing the melt, like the warm water, which is going beneath the ice shelves and causing friction and calving, and then also causing melting. So how do we want to tackle all these issues? We want to focus on the past trends and past observations, determining the present state, and then looking at the future by using reconstructions, observations, and projections from different kind of data sets, using in situ measurements, ice cores, remote sensing, and also modeling components. And as you can see here in the schematic, the ice sheet is connected to many different other parts of the climate system, like the atmosphere, the ocean, and the earth beneath, and different like surface mass balance, calving fluxes, and basal mass balance are also determining how the state of the ice sheet is. And we want to focus here on different components. We didn't come up with specific questions because we have the feeling that the questions are so diverse and so many that I just want to highlight here that we want to address the complex relationships between the different components, like between cryogenic processes, oceanography, geology, ecology, and the climate change in the Antarctic region, by really looking at all the interactions between the different components. A big part of our theme are different initiatives. Some of them are already existing, and I want to point out here that we are working on different levels. Like Necklace is more of a small project, which I'm going to introduce in a minute, but then we are also on bigger parts of the bigger projects like RINGS, which is a SCAR action group, and then even on the higher levels like InSync, which is a SCAR scientific research program. And these existing initiatives are also going to continue throughout Antarctica InSync and into the future. But these projects are kind of aligning with our research priorities and the important things we want to cover in the theme. As mentioned, the Necklace is focusing on basal melt rates by using APRES measurements around the entire Antarctic continent, especially on the ice shelves, to get a better observation on the basal melt rates. And it's a really good ground truth for validating models and satellite data sets. So here it's really important to combine the in situ measurements with other data sets to really get a good grip on the melt rates. But it's also still needing that we have a better community engagement and to extend the melt rates, the measurements of the melt rates throughout the next years and also during the InSync phase. I also already talked about RINGS, which is the SCAR action group, and the main focus of RINGS is to get a really good estimate of the bed topography at the margins and especially at the grounding lines. So they are currently in the process of mapping the grounding line around the entire Antarctic continent to have a good reference of the bed topography and data sets for that. But then the focus is not only on the grounding line, but also on the seaward and landward rings next to the grounding line to have a really good prediction of the future retreat of the margins and also on the melting rates in these parts. Recoil is another initiative, which is also focusing on ice shelf melt. And it's also using different data sets, in situ measurements, satellite and oceanographic derived estimates. And the aim is also here to reduce the discrepancy between current satellite observations and in situ measurements. And here it's also very important to have this connection to ESA to really get a good estimate and reducing the discrepancies between the different data sets. So here it's already also a project which is already running, which had a workshop last year. But also for the future, there's still a lot of work to do. For example, how to evaluate the field campaigns, but also to have ice shelf laboratory style campaigns to really know what the different data sets are telling you. We also have projects which are more focusing on the ice sheet itself, like the Plateau InSync expedition, which is still pending logistical implementations, but the science plan is already out there. This project is also an international collaboration effort with different nations, as it's mentioned here. And it's focusing on the ice sheet and how the climate change is, like how the response of the Antarctic ice sheet to the current climate change is right now. And it's focusing on borehole thermometry, on the different ice core locations which are mentioned here on the map, but it's also addressing surface mass balance on the ice sheet to really get a better estimate on all of the physical processes which are then incorporated into future projections and models. Another project which is also focusing on ice shelves is the Runner Ice Shelf project, which is kind of addressing all components related to ice shelves to get a really good understanding of the processes from the grounding line to the coast and then into the ocean, with different expeditions planned to have a base logistics on the ice shelf with a depot, and then having different traverses and different measurements from UAVs, including modeling perspectives, APRS measurements, oceanographic measurements, CTDs, so all kind of measurements to really quantify the ice shelf processes. And as a last project, I also want to highlight here that we are also interested in interlinkages with other InSync themes. This project is an example where we connect with the benthic ecosystems to really know what are changes in the ice sheet and on the ice shelf having an impact on the ecosystems which are living in front of the ice sheet and the ice shelves. Yeah. And I don't have the last slide with all our information, but if you would like to connect to any of these topics, or if you have any other projects which are aligning with the Theme 3 interests, then just reach out to us. You can find all of our information on the website itself, or just post your questions in the chat in the end. Thank you, and I hope I was time.
Thank you really much, Alexandra. And now we must jump to the next talk. And that is improving knowledge and protection of the unique Antarctic life from land to ocean and into the deep sea. And from that, we have today Sian Henley.
Hello, everybody. Thank you very much for sticking with us until this time. So I am Sian Henley. I'm the outgoing co-chair of the Southern Ocean Observing System, and I'm based in Edinburgh in the UK. But I want to make it very clear that this is a team effort from lots of people from Theme 4. And I noticed that we're joined by Helena Hare, who will be giving this presentation on Thursday. And I want to just acknowledge Nadine Johnston, who did most of the legwork in putting these slides together, and can't join us today because she is in the Southern Ocean. So Theme 4 is all about life. It includes life from right on Antarctica out into the deep ocean. So it includes terrestrial and marine ecosystems. And I think that's a really important point to grasp, because historically these two have perhaps been quite disconnected, but Antarctica InSync provides an ideal opportunity to bring these together. So in the talk today, I'm going to be talking mostly about the Southern Ocean, but keep in mind that there are parallel efforts going on for the terrestrial community and efforts to link between the two. And I also want to reflect that everything that's been said in the first three themes is also of relevance to life. So as well as thinking about the themes individually, I want us all to be thinking about the interconnectedness among the themes. There we go. So in terms of Southern Ocean ecosystems, I think it's important to remember that there's already a lot of work that's been done in this area based on a long history of Antarctic and Southern Ocean research. And the major recent efforts have shown us that Southern Ocean ecosystems are unique and highly productive, perhaps surprisingly productive to a lot of people. They comprise species that are resident in the Southern Ocean year-round and those that migrate in and out. They're adapted to a cool and thermally stable environment. And they occupy a range of habitats all the way from the land out to the deep ocean. But importantly, and we're really only getting to grips with this fairly recently, the degree to which these ecosystems are under threat and need our protection. So there's already a lot of research going on in this area, and what I want to highlight here is that there are a lot of organizations that are already working in this space and have been thinking about these research priorities for a good amount of time. So with Antarctica InSync, we are not starting from zero, okay? And a lot of these communities have very recently done analyses of the major priorities of Southern Ocean and Antarctic research. And so what the unique opportunity of Antarctica InSync is for the international community to come together to design a circumpolar program of synchronous assessments that can really move us forward on some of these key questions, key challenges, and key priorities. So some of these aspects that have recently been highlighted are that Southern Ocean ecosystems are, of course, globally connected and provide important ecosystem services. So the science is not just important for scientists who care about this kind of thing, but really everybody on Earth should care about this because they are all affected with respect to climate regulation, as other speakers have talked about, biodiversity, its role in fisheries and tourism, and then the provisioning ecosystem services of carbon and nutrient cycling, as Leah spoke to us about earlier. But these ecosystem services, like the ecosystem itself, are threatened by a range of global and local drivers. And it's very clear that they are already changing in this context, and that the changes to date and that are expected to continue will have global consequences. So what is happening in Antarctica and the Southern Ocean does not stay there. It really does impact at the global scale. And importantly, when we think about the kind of use of science and its utility in informing policy, it's very clear that we need urgent action to protect these vulnerable ecosystems against the various stresses that they're facing. So there is an urgent need for effective management and conservation policies at both the local and regional scale. And in order for these policies to be effective, they need to be underpinned by robust scientific evidence. So there is a need for systematic and sustained long-term measurements of the state of the habitats themselves and the biota that live within them. And only by generating these measurements or observations will we be able to make accurate assessments of change and therefore manage the changes occurring and make robust future projections of continued change. So there was a question earlier about the use of ecological modelling within SYNC that may fit most naturally within this theme, and then we will integrate out to the wider effort. And of course, there needs to be an international recognition of the importance of the Southern Ocean in the Earth system and global action to curb climate change and ocean acidification. And in order to provide the underpinning data for all of these things, we need international collaboration and coordination. And Antarctica InSync is an amazing opportunity for us to pull together and achieve that. So some of the key questions that have been highlighted in efforts of these international collaborative organizations, a very important one was the Southern Ocean Action Plan as part of the UN Ocean Decade. And this pulled together lots of different organizations from the Southern Ocean. It intended to be as inclusive as possible in this process to examine the key questions. And you can read those on the slide, but they really are quite all-encompassing of what we need to know about Southern Ocean and Antarctic ecosystems and how we protect them. So in terms of what Antarctica InSync can do to help, it can really, as I've already touched on, provide the basis for a network of generating the measurements that we need to understand this system and assess the changes going on. And by using those observations, we can identify the key mechanisms and the key roles of biological processes in the larger system. And then we can develop robust and quantitative projections using the data generated. And as Alex touched on earlier, Antarctica InSync is also an opportunity to standardize our protocols to be able to compare among different data sets. Yeah, so in terms of the next steps, I've talked about the ocean and the terrestrial communities. This is really an opportunity for us to come together to design something that is coherent and comprehensive between the terrestrial and marine realm. We need to talk to other scientists and other stakeholders, work on standardizing our protocols, but also make use of the huge amount of existing data that's already out there. And of course, attract the funding to do all of this incredibly important work. And I just want to finish by emphasizing the importance of inclusion, and that's of all disciplines, all career stages, all nations, and particularly making efforts to include those nations that don't traditionally have a significant Antarctic infrastructure or big polar programs. So I'll leave it there. There's some contacts from the different groups involved. Thank you again to my co-authors, and thank you for listening.
Great, thank you very much, Xian, for your talk. Now we need to continue with our next speaker. He will the talk is Anthropogenic Signatures in Antarctica, the Race Against Pollution and Other Pressures. And today we have Si-Young Chi to present that.
Good morning, everyone. Thank you, Diggy, for the introduction. I would like to continue the presentation for the Antarctic InSync Team 5, Anthropogenic Signature in Antarctic, the Race Against the Pollution and Other Pressure. This presentation is on behalf of my the German National Coordination Team for Team 5, Annette Künstler from German Environment Agency, and Ralf Iminghaus from Helmholtz-Zentrum. Since the first person stepped on Antarctic 200 years ago, and the Antarctica have been facing to the human impacts, and nowadays the increasing activities from human being and also the repeated industrialization, this accelerated climate change in the polar region and driving rising sea temperature, ice melt, and acidification. And besides, the man-made chemicals can reach Antarctica both through long-range atmospheric transport and also oceanic current transport, and from the local discharge, and especially from the research stations. And also the growing influx of tourists is large. It risks disrupting Antarctic pristine ecosystems and disturbing sensitive wildlife populations in their nature habitats. Also, The increase in shipping traffic elevates underwater noise pollution, disrupting deep water marine species and their acoustic environments in Antarctic waters. And finally, expanding human activities in Antarctica threaten the native biodiversity and increase the risk of invasive species introduction. During the production and application of industrial chemicals, this chemical can be released into the atmosphere and also to the ocean water. And this chemical transported to the polar region, especially to the Arctic and Antarctic. And during the transport, also different transform process going on, and transform to more like toxic, can transform to more toxic chemicals. The chemical pollution, which will be focused on for this theme, will be including persistent organic pollutants and also emerging contaminants such as PFAS, personal care products and pharmaceuticals, microplastic, and also plastic-related chemicals. We are focused on their transport process from the continent to the Antarctic through air and ocean current, and also to study their interaction between different environment matrices, for example, air, water, air, snow, air fluid exchange processes. And also we are going to explore their emission from the melting glacier ice and also melting snow. And we are also studying their bioaccumulation between fish, birds, and also marine mammals. And you have seen from this figure, Antarctic tourism blooming in this year from 1992 to 2023. The number of tourists increased almost 100 times, and until now, every year the number of tourists include more than 100,000, and the most increased country are like China, Germany, and Canada. Although this number is not quite large, but these people, they usually reach the peninsula. They are accumulated there, and so their effect can be higher for this specific area. So in this topic, we are going to evaluate the discharge of chemical pollution in Antarctica by recent tourists, and also try to observe the potential ecological impact, and also developing effective management among policymakers for the tourism and also scientists to protect the Antarctic species. We are going to use the research basis and also use the research vessels, like working the Antarctic. And for example, we are going to set up high volume active air sample at the different research stations, and all coupled with the passive air sampling. And also we will collect snow ice core to study the accumulation of the chemicals in the Antarctic, and also to try to collect different species, for example, fish, krill, penguin eggs, and also other species, to study the bioaccumulation and their impact to the marine organisms. And we also use research vessel to study their re-emission between the seawater and the glaciers, and also study the accumulation in the sediment core. So far, we suggest 4 working groups. The first group is synthetic monitoring of chemical pollution and management, and the second is underground water noise monitoring and aggregation. And the working group 3 will be tourism impact assessment and management, and the working group 4 is about security and invasive species prevention. And the overarching goal is to develop an integrated monitoring concept for the human impacts research in Antarctica. We have created a link and also a QR code. And with this, I would like to thank you for your attention and welcome to join our team. Thank you.
Thank you very much, Sayong. Really nice talk. And now, last but not least, we have Julia Schmaler with the talk Aerosol Cloud Interaction and Radiative Feedbacks.
Okay, perfect. Hello, everyone. I'm Julia Schmaler. I'm based at EPFL in Switzerland, and I'm talking on behalf of the group members for Theme 6. So we're 6 group members, and on Thursday, Markus Frey from BAS is going to present. And yeah, so we're really happy that we've officially become Theme 6 on aerosol cloud interactions and radiative feedbacks. And you've already heard in the introductory talk and also the modeling motivation why aerosol cloud interactions are important, and also the radiative feedbacks that result from there. So to introduce the theme, I first want to focus on why are we interested on the cloud aspect of the aerosol cloud interactions. So there's significant variability in climate predictions over the Southern Ocean, and that actually originates from the poor representation of the cloud cover over the Southern Ocean. And so also very clearly the presence of clouds or absence of clouds has a very marked impact on the energy balance, specifically also the surface energy balance. And so this is a figure that shall illustrate this bias, right? So this is a data product, so Cirrus and MODIS. Here we're looking at shortwave cloud radiative effects, and this is the annual bias by one of the CMIP6 models. So you can see there is a high bias for the shortwave radiation that reaches the surface, which means there's not enough clouds in the climate models. But it even goes further. So if we look at the liquid water path, so it's way too small. So there's not enough liquid droplets in the waters. And on the contrary, there's too much ice crystals, right? So what happens is because there's too many ice crystals, the clouds start precipitating. So we have snow or rainfall and they vanish. And this makes then the positive shortwave radiation bias. So this shows you, and also if you look at the magnitude, it's actually quite significant. This shows you why the clouds are very important. And so the consequences, if we start modeling with clouds like this, is that we have sea surface temperature biases, so up to 3 kelvins, even in the subtropics. That's incorrect simulations of sea ice extent and behavior of sea ice, the position of the tropopause jet, so for wind systems, it's very important, the storm track location, and also it generates a substantial bias in the top of the atmosphere reflected shortwave radiation. So that's all very good reasons to understand cloud formation over the Southern Ocean. And cloud formation is linked to the presence of aerosols, because only with either cloud condensation nuclei that form liquid droplets or ice nucleating particles that are responsible for the ice crystal formation, the clouds will form. However, the knowledge that we have on the sources of the CCN and INP and the processes and how many those are is extremely poor, because much of this is easier observed in situ rather than by satellite remote sensing, because the clouds inhibit much of the view and also concentrations are quite low. So it's not an easy task. This paper here showed what's the impact of ice nucleating particles. So this is a cyclone system as observed by a satellite image, and you see the shortwave flux. The scale is here. The global model, if it's in default mode, just doesn't get the shortwave fluxes. And only once we have included a better scheme for the ice nucleating particles, we can actually represent the shortwave fluxes much better. So this actually shows us how important it is to constrain the ice nucleating particles. So they can be primary, but they can also be secondary processes that we would like to study. Right. So understanding the aerosols, and I'm just giving an idea of the ice nucleating particles. There's also many questions we can address considering the cloud condensation nuclei, like the sea spray that Martin showed earlier, that if we don't include them correctly, then we can't get the radiative properties of the clouds right. And then for the sources, we need to understand the ocean, the sea ice decline, the land ice, and so on, because they all have an impact on the sources, but also the transport of these particles to cloud level. And so there's a lot that we can study. Our group has come up with a scheme here with potential processes, and there is a lot of aspects for probably many people attending this webinar, so you can find yourself in this scheme. We'll be looking at physical processes, so solar radiation, and also the terrestrial long-wave radiation, turbulent exchanges, momentum, so how is the sea ice moving? What about precipitation, snow on sea ice, blowing snow? What about the biological aspects, because they can be very important as ice nucleating particles. And then obviously the surface characteristics change drastically from the open ocean over the marginal ice zone, over the pack ice, and then the continental ice. And all of this influences then the clouds, and it's a coupled effect, of course. So very importantly, the rapid sea ice decline is linked to atmospheric responses and feedbacks, and also the mass balance and the surface melt area on the inland ice is a function of atmospheric responses and feedbacks. So overarching objectives, just to mention two, the atmosphere of the Southern Ocean region is closely coupled to the ocean, sea ice, land surfaces, and ice sheets via a broad range of coupling processes, as you saw on the slide. Many of these processes are poorly understood, so we'd like to understand them better. And then the observational strategy for the atmospheric component will be designed such that these processes and their roles for the Southern Ocean and Antarctic climate change can be better understood. And this shall then lead to better representation of these processes in climate models. So we'd like to collaborate with the modeling community closely. How are we going to implement this? So there's Polarstern in the Weddell Sea. We have Neumeier Station on land, and then also Conan Station. So we'd like to take a somewhat latitudinal transect, so we get the different surface types and different types of clouds and aerosol sources here. For the next steps, so we've already started writing a white paper on the overarching research questions, more specific research questions, and also the envisaged work program on the various platforms. And so very importantly, we'd like to build a larger international community for this theme. And so we'd like to know more about your interests so we can include all of this in the white paper. The best way to join is sign up on the website and then receive the newsletters so we can communicate via this. So thanks a lot.
Great. Thank you very much, Julia. Now we can continue with the last part of our webinar, and that's about what is next. So for that, maybe Alex have something to say.
Yes, exactly. Yeah, thank you very much, Diego. I hope you can still hear me fine and see that fine. So what is next for Antarctica InSync? There is a couple of interesting upcoming events. So we will have a strong presence at the UN Ocean conference in Nice in France, where there will be a number of Antarctica InSync related contributions, also from the Southern Ocean Observing System, and an event on Meteor. There is the Antarctic Treaty meeting coming up that several representatives from different nations are attending, where there will be further discussions on Antarctica InSync, as well as the infrastructure and the support of Antarctica InSync. Then very important for this, also the science community to note here, is that we will have a second interactive webinar in the second week of September, most likely. Please already mark this in your calendars. This webinar is probably going to be very different from this one. This was meant mostly as an information event, as well as to coordinate the international community better. For the second webinar, we envision a more interactive discussion in breakout groups. Then we will have an in-person meeting at Esrin to finalize the science plan that will most likely be from the 3rd to the 6th of November. So please save the date for this one as well. Then what is the next step that you can do, and really what you can do to help grow this program? Please get in touch with the coordination team and your national contacts to propose working groups. within each theme or as cross-cutting working groups, such as the remote sensing or modeling or data task teams. We will provide a mailing list for each of the themes, as well as we can also provide them for the individual working groups, and we can share these lists through our newsletter to the community. So please sign up for the newsletter, and then you can also receive the information on the respective mailing lists. Then we would like to ask you to meet in the individual working groups and meet regularly and develop really your scientific plan for Antarctica InSync, to already start drafting white papers. I think this is already happening in some themes, but certainly there can be more momentum coming up now. Also, please discuss potential expedition and other proposals to support Antarctica InSync within your national community, or whatever your dedicated funding streams are. Please also try to identify in these working groups a set of key variables. These should be essential climate variables, essential biodiversity variables, but can also be other variables that are essentially to observe the circumpolar system, and that can be collected jointly by different nations. Then we can also look at key processes, and please also in your working groups try to identify these key processes of what we need to observe in order to improve models and in order to validate remote sensing data. This is all I wanted to say with what is next, so I hand back to Diego.
Okay, thank you, Alex, for the very important information. And now let's continue with our last session of Q&A. I think there are a few questions in the Padlet. So regarding the anthropogenic signatures, we have: to what extent humanities and social science will be taken into considerations?
I think that's for Ziyong, right?
Yeah, yes.
We cannot hear. Yeah, now it works.
Yeah, Diego, can you just repeat the question? I cannot see the question from my computer.
Don't worry, I can read you the question again. To what extent humanities and social science will be taken into considerations?
Okay, yes. Yeah, actually, yeah, the human impact to the Antarctic, yeah, it's a scientific it's a scientific topic, but anyhow we should interact with the public and also stakeholders, like try to improve the management and also the policy. For example, the policy to managing the chemical, and also for example the shipping and also tourism. I think the social science or citizen science and the interaction with scientists will be high in this topic. We also welcome those colleagues to join our team.
Okay, thank you. So we have a few questions here when some of the speakers are already answered here in the platform, but I want to read it anyways, because maybe not all of you have read the answer. So here's one for the Southern Ocean and Antarctic heat freshwater carbon group, and it's in the carbon cycle. Are you planning to consider biological and ecological process, blue carbon, for example?
So I think I answered that. Maybe others can provide more detail, but yes, those are definitely within scope. I mean, and at least within the UK community, that following on from the Biopol program, which is currently ongoing, which is looking specifically at the lipid pump, well, in this context anyway. So I'm not sure if if Anna or others have, or Elise have thoughts, but those are absolutely within scope.
Okay, maybe here's another question for the same group. It's a great point about targeting observations to where they will reduce uncertainties most. Given that InSync aims to observe the entire continent, will there be a priority list produced by the working groups, committees, for the best locations for additional sampling?
Okay, I think I also answered that one, but
Yeah.
maybe Alex can provide some further comment. So there have been a few workshops, some already held and some planned by various parts of the community with intentions of producing white papers that will provide recommendations on scientific questions to focus on, with some things like methods to use and regionality. Of course, these are just, you know, advice, but they do sort of distill the scientific community's thoughts in those areas. But maybe it would be helpful for InSync to sort of gather some of these recommendations. I'm not sure what Alex's thoughts or the InSync committee's thoughts are on sort of approving any of these, officially or unofficially. Alex, do you have thoughts on how that might proceed?
Yeah, I guess there should be also regional focus areas for sure. I think that is something that we have been discussing all along, and I think that certainly that would be a possibility to emphasize on certain processes and key regions to observe them and also get an understanding of regional variabilities. Yes.
Okay. I'm reading the questions here in the panel. I know that many of them already have an answer, but I just want to discuss here with all of the people attending the webinar. So here's another question for the melting ice sheets and ice shelves and coastal impacts group is, do you have any observational plans for a supraglacial hydrological system? Such features are quite common in Greenland, but remain rare in Antarctica, though mature systems have already been documented. I think Alexandra already answered in the chat, but maybe she can mention it here for all the audience.
Yeah, I think it's just what I wrote there, that it's sometimes already considered, but yeah, it'll be part of future research as well.
Okay. Now,
just maybe I quickly wanted to mention there is a couple of questions in the WebEx chat. So we had provided a link to transfer the questions to the Padlet, but we will try to record the questions in the WebEx chat as well and answer them later on the Padlet maybe.
So here is a general question in others, and is, are there plans to develop an official training component, ECR, field school as part of Antarctic InSync?
Yeah, I'm happy to take this one. So I think, yes, that is definitely the plan. We have been discussing this with several groups to provide very dedicated schools and trainings for anyone that wants to join. These can be how to deploy an Argo float and how to analyze Argo float data. This is just an example, but we can certainly think about other trainings, and I think this is something that is still under development, how this will go about, but certainly most likely in the year 27 or so, there will be an intense period of trainings and courses, yes.
Okay. Here, I will read a question here in the web chat is our general one. Could you be so kind to explain better how to join the teams and which role should play the national coordination committees listed in the website?
Maybe I can take on that one. So yes, so the national committees are really meant as a like kind of linkage between the steering committee and the science community to really like to get the information from one board to the other, and to have it not only as a top down process, but really like to grow this from the community. And this is why we need these, or like why we thought that it would be helpful to have these national committees to there kind of organize locally and to make sure that you get everybody involved who should be involved and who want to be involved into the whole process, and that no information is kind of lost along the way.
So here's another question in the chat, in the web chat, is how to operate when proposals are international and not national.
Yeah, that is a good question. I think if there is an international proposal, I guess it's good to organize within your theme or working group when you're applying for an international call, depending on what it is about. So I'm sure this can be organized within the working groups, and what aspects need to be included. If you do apply for such proposals and calls, please let us know, also that we can keep track of this information centrally with the coordination team.
Good. So, well, just a general, I don't know, information for the people who is attending this webinar is that the easy way to contact us is please go to the webpage, get registered there, and as well, you are more than invited to follow up in our LinkedIn profile, because those are our official channels, communication channels, where we put all the information that we have, we can spread. And regarding how to get involved, that's why we have the national committees. But of course, you are always welcome to contact us directly, the coordination team, and we'll try to answer your emails or questions as soon as possible. I don't know if there are more questions or information to share.
I don't think so currently. So yeah, just thank you very much again for all the presenters today and all the speakers, and sorry for running slightly over time. Yeah, I hope to be engaged with everyone throughout this program, and I'm very much looking forward to seeing how it grows.
Thank you very much to the speakers and for all the participants again, and have a nice day.